Welcome back. Now we want to look at laws of indices. Okay, so we have 6 laws of indices and we want to look at each and every one of them, and afterwards we're going to be looking at examples to see how we can apply these laws of indices in solving problems. Okay, so let's start with the first one. Now, according to the first law, we say a to the power of m multiplied by a to the power of n will give us a raised to the power of m plus n. So we'll be saying when multiplying numbers having the same base, the indices are added. So that is what this law is all about. For example, let's say we have 2 raised to the power of 2 multiplied by 2 raised to the power of 3. This will give us 2 raised to the power of 2 plus 3, because remember we said that we add the indices, we add the powers. So that's what we get here. We simplify. 2 plus 3 is 5, so it's 2 to the power of 5, and this is 32. That is multiplying 2 5 times by itself, so we get 32 right there. So that's the first law of indices. And the second law has a division. We'll be saying a to the power of m divided by a to the power of n. So what we get is a to the power of m minus n. So we're saying here that when dividing numbers having the same base, the indices are subtracted, like you're seeing here in this law. So we can look at an example where we have 3 raised to the power of 3 divided by 3 to the power of 2. Since the bases are the same, then we subtract the powers, so we get 3 to the power of 3 minus 2, and that is 2 minus 3 minus 2 is 1. Any number to the power 1 remains the same, so our solution right there is 3. So that's our second law of indices. Okay, let's quickly move on to the third law of indices. Alright, according to the third law of indices, if you have a to the power of m and it's raised to another power n, then this will be equal to a to the power of the product m times n. So this is a to the power of mn. So we'll be saying if a number raised to a certain power is raised to a further power, the powers are multiplied. For example, we can be having 2 to the power of 2 raised to another power 3. So in this situation we multiply the powers, so we get 2 times 3 for the indices there. So this will give us 6 to the power of 6, which is equal to 64. So that will be the solution right there. So you need also to know this third law of indices. The fourth law has to do with a base raised to the power of 0. So any number raised to the power of 0 is equal to 1, no matter what that number is. So if you have, say, 3 to the power of 0 is 1, 5 to the power of 0 is 1. Whatever number, whatever base raised to the power of 0 will be equal to 1. Always know that. Okay, so that is our fourth law of indices. Okay, let's move on to the fifth law. The fifth law has to do with negative powers. Alright, so if we have a base raised to a negative power, for example, in this case we've got a raised to the power of negative m being equal to a to the 1 over a to the power of positive m. According to this law, a number raised to a negative power is equal to the reciprocal of that number raised to a positive power. Okay, so this is what this law is all about. The word reciprocal here is of interest. Reciprocal, the reciprocal of a number. If you have your, say, your fraction a over b, the reciprocal of a over b will be b over a. In other words, you invert. The numerator becomes the denominator becomes the numerator. That is what we call a reciprocal. So if you have a to the power of negative m, like we have right here, we've got our a to the power of negative m. The denominator of a is 1, right? Because any number, if it doesn't have a denominator, then its denominator is 1. So we invert it, or we find the reciprocal where the denominator 1 becomes the numerator and a becomes the denominator, but now it will be raised to a positive power. So that's the key thing right there. That is the key thing, very important. So we can have an example. If we have, say, 2 to the power of negative 3, the denominator here of 2 is 1, right? So this will be equal to the reciprocal, which is 1 over 2, now raised to a positive power 3. So this will give us 1 over 8, and that will be the solution right there. So another example, let's say you had 2/3 raised to the power of negative 2. Since we have a negative power, then we find the reciprocal, so it becomes 3 over 2, and now the power becomes positive, and 3 squared is 9, and 2 squared is 4. So this will be your solution as an improper fraction. So that is what we have to, that is how we deal with the negative powers. You find the reciprocal of the number and the power becomes positive. Okay, so let's move on to the last law of indices. We're going to be applying these laws in solving problems very soon. According to the last one, which it has to do with fractional powers. If you have a raised to the power of m over n, which is a fraction, then you get the nth root of a raised to the power of m. So here we are saying when a number is raised to a fractional power, the denominator is the root of the number and the numerator is the power. So you look at the fraction, and the denominator, in this case n, becomes the root of the base. So that's why we are saying nth root of a, and the numerator, in our case we've got m, the numerator right here becomes the power, so we raise a to the power of m. So we can look at an example that illustrates or that uses this law. 4 to the power of 3 over 2. So this will be equal to the square root of 4 raised to the power of 3. Now the square root of 4 is 2, so that will give us 2 to the power of 3, and 2 to the power of 3 will eventually give us 8. Alright, so these are the 6 laws of indices. I hope you were writing them down one by one. If you were not, I want you to get a piece of paper and play back this video starting from the start, and start to write down all these 6 laws of indices, and make sure that you find some time to meditate on them. Make sure that you know all of them and you understand how I've been using them, so that you can be able to solve problems like what we are about to do. Alright, so I'm just going to give you a few minutes to do that, and afterwards we're going on to an example. Alright, so let's look at this example. We want to simplify the following. So we've got a, b and c. So we want to simplify these 3 problems right here. Alright, so what I want to do is I want to give you just a few minutes to work these ones out and apply the laws of indices to see if you can simplify them and come out with the right answer. So I want you to pause this video starting from now. Alright, so this is the solution. Let's start with part A. In part A we have 2 to the power of 3 multiplied by 2 to the power of negative 6 divided by 2 to the power of negative 10. Okay, so this is quite straightforward because we have the same bases. We can apply law 1 and law 2 quite easily right here. For the numerator, for 2 to the power of 3 multiplied by 2 to the power of negative 6, we apply law 1 where we add the powers, so we'll be getting 2 to the power of 3 plus negative 6, and this is divided by 2 to the power of negative 10. So if we simplify 3 plus minus 6, we get minus 3 because it's like 3. If we have a plus and a minus, we get a minus, so it's 3 minus 6, and that's minus 3, and that's divided by the power of negative 10. Alright, so this will give us 2 to the power of, because now we are looking at a division, so we subtract the powers. Remember law number 2. I hope you have that law on your piece of paper and you can be looking at it right now. So we subtract the powers. It becomes minus 3 minus of minus 10. So we are now applying law number 2 to divide 2 to the power of negative 3 divided by 2 to the power of negative 10. Now the minus and the minus gives us a plus, so it becomes minus 3 plus 10, and minus 3 plus 10 gives us the power 7. And let's just have a little bit of space. Okay, and 2 to the power of 7 is 128. Okay, so that is the solution to part A. Let's move on to part B. We have 125 to the power of 2/3 multiplied by 5 to the power of negative 2. Okay, so we can be applying our sixth law of indices, that has to do with fractional powers. So 125 to the power of 2/3 will give us the third root of 125 squared, and this is multiplied by, on 5 to the power of negative 2 we have a negative power, so remember what we said, we invert, so it becomes 1 over 5 to the power of a positive 2. Okay, so having this, we can simplify. The third root of 125 is 5. Right here, the third root of 125 is 5, because we know that 5 cubed is actually equal to 125, right? So the third root of 125 is 5, so that would be 5 squared multiplied by 1 over 5 squared. And when I'm here, I'm seeing that my job becomes so easy because I can just cancel out 5 squared into 5 squared, we get 1, and our solution will come out as 1. So that's the solution to part B. So I'm simply using or applying our laws of indices. So let's move on to the last example. We want to go on to part C. We have 0.04 to the power of negative 1 over 2. We have a negative power, but first of all, since we have a decimal, I would want to express 0.004 to as a fraction, and it becomes 4 over 100, right? And that is raised to the power of negative 1 over 2. So I've simply expressed the decimal as a proper fraction. The power is still the same. We still have our negative 1 over 2. So since we have a negative power, we invert, so it becomes 100 over 4 to the power of a positive power. In this case, that's 1 over 2. Okay, and this will be the square root of 100 over 4, because when we have a fractional power, then that means that it's the square root of the base here to the power of 1, right? According to our law of indices, the sixth law that you have on your piece of paper. but we know also here we cannot give ourselves much trouble, because we know if we divide 4 into 100 we get 25. So this is the same as the square root of 25, and square root of 25 will give us 5. So our solution to part C is actually 5. Alright, so these are just examples that I have used just to see how, or to show you how you can solve problems involving the laws of indices. So next we're going to be giving you more examples, starting from simpler ones as we go on to more challenging ones, so that you may work on your skills of manipulating problems involving laws of indices.